Everyone, this is Mrs. Sohail Zaki from Victoria College, Alexandria, and we are going to study our first lesson in Unit 1. It's about the history of the modern periodic table. Let's start. At the first, why we want to classify elements. We classify elements to find relations between physical and chemical properties of the elements and to be easily studied these elements. The first trial to classify elements was Mendeleev's periodic table that contained 67 elements. What did Mendeleev do? He made a code for each element and write the name and the atomic weight and the symbol and the properties that he knew for this element. Then he arranged the element in ascending order according to the atomic weight. He found that by beginning a new row, a new horizontal row, the element properties repeated in a periodic way. So Mendeleev found the periodicity of the elements as the atomic weight increases from left to right. Mendeleev was the first scientist who classified 67 elements in one table, and also Mendeleev have disadvantage and advantage for his table. Let's see. The advantage of Mendeleev's periodic table that he discovered the graduation of properties of elements in periods and group. This is the first one. Also, Mendeleev left gaps for the undiscovered elements, such as Eka silicon that was discovered after Mendeleev and named by germanium. He left gaps for the undiscovered elements and also predicted by their properties. Mendeleev also corrected the wrong atomic weights of some elements. The disadvantage of Mendeleev's periodic table was he had to disturb the ascending order of the atomic weight of some elements to suit the properties of these elements. So in sometimes he didn't put the element in his right order to suit the properties of the elements that before this one and after this one, up and down. So he in some cases break the ascending order to suit the properties of the elements. Also, he had to deal with isotopes and considered the isotopes of the same element that have different atomic weight as different elements. What is meant by isotopes? Isotopes are atoms of the same element that have the same atomic number, the same number of protons inside the nucleus, but differ in the atomic weight because they are differ in the number of neutrons. For example, in the figure at the right, you can see the isotopes of hydrogen. The first hydrogen atom is the one that we all know. It contains only one proton and surrounded by one electron. But the second one and the third one are the isotopes of hydrogen, as the second one contains one neutron, and the third one contains two neutrons. Both of them are isotopes of hydrogen. But all of these atoms are for the same elements. So they have the same atomic number. But in case of Mendeleev, they are different elements because they differ in their atomic weight. So he considered the isotopes of one element as different elements. After Mendeleev, there were two famous scientists. The first one was Moseley and the second one was Rutherford. They worked at the same time, and by the time that Rutherford discovered the positively charged particles inside the nucleus, Moseley also was discovered more properties of the elements by using the X-ray studies, and he take the number of positively charged particles inside the nucleus that was named by atomic number, and found that the element's properties is related to their atomic number, not to their atomic weight. So Moseley made a change or a modification on Mendeleev's table. He arranged the elements according to the increase in atomic number, not to the atomic weight, because the properties of the elements are related to the atomic numbers, not to the atomic weight. At the same time, as we mentioned before, Rutherford, which is a New Zealand scientist, discovered that the nucleus of the atom contains positively charged particles. These particles are named protons, and the number of these particles was named by the atomic number. What are the modifications that Moseley made in the periodic table? The first thing, as we mentioned, is the base on which Moseley classified the elements. On it was the arrangement of the elements in ascending order according to the atomic numbers, by that increase one by one. The second modification was that Moseley added the inert gases, all of them in the zero group, at the end of his table. Also, Moseley put two groups below the table, which are lanthanides and actinides. So there are many modifications made by Moseley. The first and the most important one is that he arranged the elements according to the atomic number instead of the atomic weight. The second one put all the noble gases or the inert gases in the zero group, and allocated a position for lanthanides and actinides below his table. As we can see, if we take a row from or a period from the periodic table of Moseley, we can see that each element, as boron, for example, and carbon, if we take boron and carbon as example, we can see that the atomic number of boron is 5, while atomic number of carbon is 6. So each element is increased by 1 from the previous elements. So nitrogen will be 7. Oxygen will be increased by another 1, so the atomic number in oxygen is 8. And by adding another 1, fluorine will be 9. And at the end of the row, at the end of this period, we will find a neon which is has atomic number equals 10. So each element increased by 1 from the previous element. And if I asked you, is there any chance to discover an element between carbon and boron, you will answer by no. This is why, because there is no chance to find an element has atomic number equals, for example, 5.5 or something like that, because each element is increased by 1 from the previous element in its atomic number. Okay? Now we will discuss the modern periodic table. The modern periodic table consists of 7 periods and 18 vertical groups. These 18 vertical groups are arranged in 4 blocks. The first block is the S block that contains 2 vertical groups, which are group 1A and 2A. The B block at the right contains 6 groups, which are 3A, 4A, 5A, 6A, 7A, and 0 group. And in the middle, the D block that contains 10 columns with 6 groups. These columns are named by 3B, 4B, 5B, 6B, 7B, and group 8, which includes 3 columns by itself, then group 1A and 2A. In D block, there are a certain type of elements. These elements are called transition elements. Transition elements are elements that lie in the middle of the table in D block. These elements, each one of them has more than one valency and form colored compound such as copper and iron. In copper, the element could be monovalent or divalent, and in iron could be divalent or trivalent. These elements are called transition elements. Below the table, there is the last block, which is F block, and includes 2 types of elements, which are lanthanides and actinides. How can we determine the location of the element in the modern periodic table? To locate the location of the element, we must at the first do the electronic configuration of the element. In case of sodium, for example, the atomic number is 11, so the first energy level has 2 electrons, the second one L has 8 electrons, and the last one has 1 electron. So the configuration of sodium will be 2, 8, 1. The number of the period indicates the number of energy levels. So sodium lies in the 3rd period. So sodium lies in period 3 because sodium has 3 energy levels, while the number of the group indicated by the number of electrons in the outermost shell. So as sodium has only 1 electron in the outermost shell, sodium group is group 1A. This is the name of the group of sodium and it's equal to the number of electrons in the outermost shell. Let's determine the location of these elements. For lithium, the electronic configuration, as lithium has only 3 electrons, the configuration will be 2, 1, so the number of energy levels will be 2. This means that lithium lies in period 2, and the valence electron, the number of electrons, the outermost, is 1, so lithium lies in group 1A. As we discussed sodium before, we will go forward to potassium. Potassium has 19 as its atomic number, so the electronic configuration will be 2881. So potassium has 4 energy levels. It lies in period 4, and as it has only 1 electron in the outermost, it lies in group 1A. Okay, let's take another example from this table. We will take boron, for example. Boron has 5 electrons in its atom, so its configuration will be 2, 3. This means that boron has 2 energy levels, so the number of the period will be period 2, and 3 electrons in the outermost, and these 3 electrons means that boron lies in group 3A. For carbon has 6 electrons in its atom, so its configuration will be 2, 4. 2 energy levels, this means that we are in period 2, and 4 electrons in the outermost, this means that carbon lies in group 4A. Let's solve this question. The number of the period equals the number of energy levels, or the number of electrons in the outermost level, or the atomic number. Of course, the number of period equals the number of energy level. The number of group is the number of energy levels, or the number of electrons in the outermost, or the last element. Of course, it is the number of electrons in the outermost. According to the electronic configuration shown in the opposite figure, this element lies in the dash group and dash period. As we can see, we see only 3 levels. This means that the element lies in the third period, and the element has only 1 electron in the outermost, so its group is group 1A group. Which block contains this element? This element lies in group 1A, as it has only 1 electron in the outermost, and group 1A is located in S block, so we gonna choose S block. Okay, I hope that you understand our lesson today, and we will meet in another lesson. Goodbye for now.